So now I'm going to show you how to do partial quotients division on paper. So we've got our original number, which was 564. And we're going to make this into a division problem. You're going to draw what looks kind of like a hangman gallows, like if you were playing hangman with friends. So 564 goes underneath, and then next to it, we've got the number of equal groups that we're trying to make. Remember, it's 4 because we've got 4 founding fathers who are sharing Ben Franklin's stash of chocolate. So we started out passing out the chocolate by passing out whole bars of chocolate. Now that's really a great way to start because each of these is worth 100, and 100 is a nice friendly number that's easy to multiply. Other friendly numbers include tens and multiples of tens. So when you think about multiples of tens, you're thinking about 20, 30, 40, 50, 60, 70, 80, 90. 5 is another really easy number to multiply, and so is 2. So we've handed out 100 to each of these guys. We keep track of how much we've handed out over to the right of our problem. And then once we've handed out some of the chocolate, we draw a line underneath. We figure out how much altogether we've handed out. Each person has got 100, but altogether that equals 100, 200, 300, 400. So 100 times 4 equals 400 total pieces of chocolate we've already handed out. Now we've got to figure out how many pieces of chocolate we've got left over that we've still got to deal with. 5 minus 4 is 1. There's still 164 pieces of chocolate left over. Well, I don't have enough left to give everybody another whole chocolate bar, so I'm going to have to go with a smaller friendly number. Perhaps we could go with 10. So if I handed out 10 to each founding father, 1, 2, 3, 4, then I've handed out a total of 40 pieces of chocolate. Again, we've got to figure out how much do we have left over. 124 pieces still left. Well, that only took care of 40. I'm wondering if I can go a little bit faster. Instead of just giving out 10, could I give out more than 10? Well, let's take a look at what I've got left. 124. Well, I know if I ignore that 4 for a moment, that's going to be 120, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 rods to hand out. And I've got 4 people. I'm wondering, can I do this in one step? One way to think about it is 4 times what will get me close or equal to 12. Is there a number that could fit in there? 4 times what equals 12? Well, 4 times 2 equals 8. 4 times 3, that equals 12. That means I could hand out 3 at a time. And be totally done with the rods. So 3 of these rods, are they really just worth 3? They're not. It's 10, 20, 30. So I've given each person 30. So at first I gave each of the founding fathers 1 rod, but then I gave them 3. Those 3 are worth 30. 30 times 4, well, let's see. We've got 30, 60, 90 plus 3 more. That would be 100, 110, 120, 3 times 4 is 12. And then I've got that 0. Then I see how many I have left over. Only 4 are left over. And we see that reflected over here with our place value blocks. 1, 2, 3, 4. Now that's going to be really easy to hand out. I'm just going to give each founding father 1. 1 for you, George. 1 for you, Thomas Jefferson. 1 for you, Jack. And 1 for you, Ben Franklin. If I give out 1 to each of the people, then I've got 1 times 4 and no more pieces of chocolate to give out. Now there's lots of different ways to do this problem. You don't necessarily have to start with 100, and you certainly didn't have to do 10 next. I'm going to show you one more way to do it. I'd like you to just watch and see if you can figure out how I've done things differently. Now I'm thinking 4 times 4 equals 16, and I've got that 0. It's really, really easy to multiply with multiples of 10. Only 4 left over. Now all I have to do is hand out 1. And I'm done handing out pieces of chocolate. Now after you've done this problem, you can see this one I did in 1, 2, 3 steps. This one I did in 1, 2, 3, 4 steps. You could certainly do it in more or fewer steps. It's really up to you. I still haven't written down my answer. Now it's time to write down the answer. So each founding father has 1 full block of chocolate, 100, 4 rods of chocolate, 40, and 1 individual piece of chocolate. So that's 100 plus 40 plus 1, 141. We can see that reflected over here as well. All I have to do is add up what I handed out. First I handed out 100, then I handed out 10, then I handed out 30 to each person, and then I handed out 1. Well, altogether, that equals 1. 1 plus 3 is 4. And 100, 141. I write my answer up at the top. Here my adding is a bit different, maybe a bit simpler because I only did it in 3 steps. 100 plus 40 plus 1. 141.